So this is going to be our third tutorial, so I'll apply new model, right? So now I'm going to show you how to model a water tank, something like that, right? So that's not going to be a frame, right? That's a shell type. Okay, so shell type means that, and shell type means wall, right? So that means probably a wall will be pressurized and wall taking the load, right? The water pressure. And how are you going to model that, right? So I keep these models. So I'm going to get it a shell, right? So the cylinder option is already there, barrel shell and multi-cylinder shell, partial sphere, spherical dome, everything is there, right? Parabolic dome. So I'll go to cylinder. So cylinder height is given. So I will check it's I will say that is 5 meters. Okay. No, sorry, 6 meters. Okay. So radius I will set radius I will set it's like yes, I will keep it as 2 meters. Number of divisions means these divisions, right? So that actually that is 3, but I will define it 6, right? It's, I think it's not showing in this figure. Angular division means along the circumference. Circumference, how many divisions you need? I will keep it as 16. That's default. Restraints are there, grid lines are there. Areas, you haven't still assigned anything, right? So can you see? There is no any elements, frame elements there, right? Straight members are there. Everything is an area element. It's like this. Sections, it's not areas, sections. Sorry. Extrude, fill objects. You see? So thickness and wall, no any beams or columns or likewise frames are there, right? It's just a concrete cylinder, right? This is the wall. That wall takes the load, right? That's our idealization. So I'll just remove this option, right? So its cylinder is already pinned at the support. So you need to determine. So if this is placed on the ground, so you don't need to model the bottom slab, the bottom slab of the cylinder. So the wall is only enough, and you can, even if you not to fix it, you can fix it and see. So I told you how to rotate it and select the joints, and then you can assign any fixity, right? Even fix. So I have determined pin here, right? So that's okay. Now the advantage is we don't need to draw area elements, right? It's already drawn because that's a system giving us this structure, right? So what we need to do is we can select again the materials. So I'll copy material, matcon, concrete. So it's going to be 25. Other things I keep same. Okay, right? So now it's not a frame element, it's an area element, right? So we are still giving under shell sections, right? Shells, okay. So copy of section. This is going to be cylinder wall, right? So there are several shell thin. So these are not needed for you. Shell thick, plate thick, not needed. I just want you to know what is membrane, plate thin, and shell thin. I'm not going to explain what's the difference, right? There's the wall thickness, okay, membrane. So I'll select it's 0.25, that means 0.25 meters thickness. So you have to define what is this, right? Material, I will say metcon. Other things are okay, no need material angles. The things are okay. So I'll call this for now a shell thin. Okay. So then it's okay, right? Everything okay. So you have to determine each of these sections, shell thin, plate thin, and membrane, and see what happened to the results and how you going to interpret that and check manually as well. So I will do a video later how to do it using manual calculations and other things, how to idealize it. The first thing is, you know SAP, right? But you are not an expert. Even I'm not an expert in SAP, but I have taught you what I know, right? So what I know is I know how to interpret the result. So I need you to learn those, and if I will help you to do that as well in a later video. First, now the important thing is you have to at least give a try, right? So okay, so cylinder wall is created, okay. So I have to assign this. I'll select each and every section and just like that assign now area sections, not frame section. Cylinder wall is there, okay. Cylinder wall, right? So now it's okay, and we define load patterns. I don't need the self weight for now. I will modify that. Okay. I will define something water pressure, water load or water pressure something. It's a kind of dead load. I don't need self weight as well. Add new. That's okay, right? And from water pressure is always, you know, pressure is perpendicular to the surface, right? So there is a unique way to assign this, because the pressure is not uniform, because you have zero pressure at the top and the maximum pressure at the bottom. So one good thing you can do is you can calculate that force. So that's going to be like this. Hope you can see this screen. It's like this. If your tank is like this, so your pressure is zero at the top and the maximum at the bottom, triangular variation, right? Oh, shit. This is the side view of the tank, right? This is, and your pressure is like this, you know. This is, so I would say this is X, Z is measured from the bottom as I saw, right? So let's say at the X level, your water pressure is this height, Z minus, sorry, this is Z is the axis. So total height is H. Total height is H. So this height would be H minus X. So that pressure would be H minus X rho into G, right? Rho is 1000 and G is 10. This is 1000 kilograms per meters cube. This is 10, right? So when you multiply these two, right, that's going to be G is 10, right? So 1000 kilograms per meter squared, right? So this is going to be kilograms means this is going to be how much newtons? Rho is 1000. I think this is going to be 10, right? Newtons, you have to make it Newton, you have to divide it by, is it 100 kilograms, 1000 kilograms per meter, right? So what you need to do is, so this is, I think, not needed to use. So what you need is specific weight, right? Kilonewtons per meter cube, right? And you have 1000, right? Kilograms per meter square, meter cube, right? And 1000 means how much newtons. So you have to divide it by, multiply it by 10, right? So multiplied by 10. So that's going to be this one, right? Right. So that's going to be not, actually this is not. When you multiply it by, so make it Newton, and it's going to be 10,000 newtons, and that's going to be 10 kilonewtons. Still per unit meter, meter cube, right? So that's a specific weight, right? Specific weight into h minus x, right? So you know the total h. So you can determine what's h. So that's going to be 10h minus 10x. So this is going to be y equals mx plus c. H is 6, right? So that's going to be 60 minus 10x. This is the load we need to define, right? To mathematically idealize the water pressure. 60 minus 10x. This is the load at x equals h. The pressure is 0 at x equals 0 at the bottom. This is maximum 60, right? So we have to define it. 60 minus 10x. So we have to define it. So how we are going to define it is, we can use something called here joint patterns, right? In here, you can define the default joint pattern using, sometimes the thing I defined in earlier water pressure will not be useful here, okay? So joint pattern is something independent. So constancy, you remember that was 60 minus 10x, right? So now my, actually it's not 60, it's z axis, right? So that is 60 minus 10 z, okay? So that's going to, because my vertical axis is z, right? Actually I made a mistake, that's z, not x, okay? So here it's not z, x, it's actually x, okay? Sorry, it's actually z, okay? Not x, so z is there, it's going to be z. So this is something called no x or y there. So this is going to be 10 minus 10 z plus 60. Right, I have to apply that. So this is constant. C constant is minus 10 z, right? That's going to be minus 10. Constant is 60, right? Okay, so I'll apply that. So it's still not added as a value. So then I will select all of these area element and assign area loads. So that's a surface pressure, right? Surface pressure, and it's a water pressure, right? It's a water pressure, right? So I need top means either the bottom side or the top side of the face, but for this one, it's not going to be that much effect. So the top actually means you need to know local axis of one of these element. So let's say the local axis of area element. This area element. So you can see. So the blue axis is always out of the plane, right? So I'm not still telling what is this 1 or 2 or 3. You have to select what is 1, what is first axis, what is second axis, what is third axis. So I will take this outer surface is the top surface. Okay. So then local axis. So inside I will take that is as the bottom surface. Okay. Or else if you want, you can just take it top because it doesn't matter, right? Assign area load surface pressure. That's going to be bottom, say, by joint pattern. Okay. Just my multiply is 1 because I already had it to it. So reply. Is it added? No, I think I did not select anything. Oh, sorry. It's not dead. It's water pressure and joint pattern. Oh, I think that axis should be the other way around. Sorry about that. Loaded thing is top surface. I will just multiply it by 0 and just replace it because whatever added then will be 0. Okay. Then I can go ahead and apply a surface pressure, water pressure, top of the surface, joint pressure, pattern. Yes, I found the mistake. What I had made is, so I haven't applied the joint pattern. I need to apply it when I'm applying the joint pattern. I have to select all and then assign the joint pattern. Okay, when assign joint pattern. Okay, it's defining and the assigning at the same time, right? Default and 10. Then okay. Can you see? Then the numbers will be appearing here, right? 60, 50, these things will be there, right? So I think I have added it 2 times. Delete existing values. Okay. Then select it, assign joint patterns. It's okay. Replace values. Then replace by this. Okay. Right. Now it's okay. 10. Yes. 10 pressure here, 0 pressure here, 10. Then at the bottoms, it's going to be 60. So I need to add now this pressure to the, so it's not, it's still the load. Okay. I at the pattern. Okay, so I have to select everything and assign. So my area was initially correct. Okay, so that bottom I need to add that surface water pressure. By default it's multiplier 1. Okay, replace existing, everything is okay. By join pattern, okay, it's okay. Can you see the water pressure is now added at the middle of each element? Let's see, it's from inside, right? Can you see it's inside? That's actually should be the out case, because even if you can apply it from the outside as well, but it's not the correct idealization, right? Water pressure acting inside, right? It's the bottom of the surface. So something to think that with local axis. So you need to have a good idea on that, right? So I apply the local axis. Now my supports are there, water pressure is there, right? I define the water pressure like in a increasing manner at the bottom and define the wall and everything, set self to 0. I can just run it. I don't need model case. Right. Water tank. You see it's giving the deformed shape, but if you need now joint reactions, water pressure, you can check what are the reactions, okay, at each joint. So that will be in global x directions. I remember you remember when I told you that, right? For shells, now you don't have any frames, you have shells, right? But in your different shells, actually it's within that shell you define it thin shell or thin plate or membrane, right? Depending on that case, you will have resultant forces and stresses, okay? You need to know each type of this. What are these? Actually, S11, S22, S211, what are these? You have to decide. So for now, you will be dealing with resultant forces and resultant stresses, right? If you want the stress, you can determine it from here. If you want forces, so let's say F11, just see. So it's giving the value, right? So when I keep the cursor, it's giving me the value. If you want some element, let's say like this, I can right click on that same element, similar to that I did in last video. Right click on that element, so that's giving. So from at the top of the element, you have 130, 127 kilonewtons. This is a per meter force, okay, at the middle and at the bottoms, right? So you have to define it with different whole section and compare it with the manually, right? I didn't teach you how to do it manually, so you have to find it a way to analyze this pressure manually, right? Wall pressure, and compare it with the different section types, plates, membranes, shells, thin, okay, thin plate, thin shells, and membranes. That's something you have to do, right? And you have to determine what are these F1 on F2 to F3, because if you don't know what to select, what to see as the result, it doesn't matter even if you model the entire thing. So water pressure, I haven't changed, sorry. So water pressure. So let's say this is M22. It's not giving anything. So what's M22? Why it's 0? So you have to determine that. That's something important. That's how to interpret the result. Why M22 is 0? What is M22? Why it's 0 in this case, right? So that's something you have to ask yourself. Even M11, why it is 0, right? What is F11? What is F1? Why it is giving such values? 106. Why it is giving something values like this? So you have to determine that, right? That's your task to do. Anyway, I'll be uploading the complete video later, how to do the manual calculation, how to compare it with your results, how to deal with different sections, what's that, right? Thank you. And one more thing. If you want to mesh it, you can still mesh this elements, right? She means discretizing, right? Discretizing these elements in such a way. If you say this element, I can edit areas and divide areas. It's going to along edge 1 to 2. I will in there will be always again local axis. Okay, in the first direction, first to 2, that's going to be 3. Let's say this is 2. Let's say this is 4. Let's say. Okay, and I just need to define. And you see, it's discretizing. So this more number of finite points are there to solve that structure, right? So if I select entire thing, I just so this mesh is random. Depending on this mesh, your accuracy will be changed, right? But at some point it will converge, right? Let's say like this, which is 6 by 6 mesh. Even that increases the computational power, right? Because more number of finite points that it had to solve, right? But its computer, it is solving very fast. SAP is fast actually. Let's check this F1 on again. We didn't have any loading. What happened to that? Oh yes, it's there, right? You can't see the color. It's there. Value is there, right? You can see what is happening when you increases the mesh, right? So you have to determine that as well. What is done by meshing, right? Dead load, water pressure. So what is actually happening at these locations, right? Why it's giving such value? So you have to determine all, right? See, it's something around. It's kind of force, right? So yes, you have to do it. Can't undo it. Okay, thank you very much.